to the ROBA for inviting me. So as Will says, I'm the director of the Green Register. We're a not-for-profit organisation, but I'm also a practising architect. Although I don't practice in a conventional sense, in that, to be absolutely brutally honest, I got fed up with clients. So I decided to take all the money out of my house, and we do our own eco-developments now. So they're very small. Last time we did was a little church hall, we sliced it up into little micro affordable houses, and I thoroughly recommend that approach if you can. But anyway, some of you may have seen me before because I was up here a few months ago. Could you just put your hand up so I know how many of you went to the ROBA half-day session I did in Gateshead? Not many. Well, if you had, some of these slides are a refresher, but since you haven't, that's absolutely fine. The other thing I wanted to mention is that there are more slides here and more information than I'm probably going to get through, and that's an intentional thing. Whenever I get an audience of architects, I like to give you as much information as possible. Now, you'll get these slides sent to you by the RIBA. So there's lots of links. I could spend all day talking about things, so what I've just done is sort of concentrated some of the slides and given you a link to look for something else. So the next 40 minutes or so, apart from just talking very briefly about who we are, is we're going to look at what this actually means, which it is all things to all people. We're going to look at some of the things, some of the drivers, why we are or we aren't doing sustainable design. The who, out of all the design team and beyond, is driving sustainable design, and crucially how we as architects can involve that and integrate that into our practices. So there'll be a big section at the end where we look at how we can actually effect change. So the first thing I want to do is to, is to tell you about the Green Register. I started it in 2000. As Will has mentioned, we do a whole range of training sessions all on sustainable design. I'm going to mention Passive House later, which we're hoping to bring to Newcastle. We are not-for-profit, so we have no restrictions on what we talk about because we're not sponsored, we're not given grants, we're not given anything that might restrict what we say. We're very independent. And there's lots of information up on the table if you're interested.
Low impact
on
the environment.
Okay, and what would be low impact on the environment? The whole building?
Energy use.
Energy use?
Yeah,
materials, that's it. Yeah, what else?
Will be durability.
Durability, yeah.
Fit for purpose.
Fit for purpose, but also adaptable. Yeah. Anything else? Anybody's ever done a BREEAM assessment will know that there's 8 or 9 categories, so it goes beyond what we just talked about. Well-being, exactly. Yeah, health and well-being. Okay, so I've listed the ones that are on my list, and they will encompass some of the ones that you've had. So the first one, of course, is, this is not advancing, there we are. That's the one that most people think of when we talk about sustainability, is its energy efficiency. Will's already mentioned well-being. That's not only well-being for us as occupants of the building, it's well-being of the planet. Somebody mentioned low-impact materials, and that's tied into the well-being of the planet. I'm going to go through all of these separately. Minimising waste, which again is connected to material use. Adaptable, somebody's mentioned. Durable, design for deconstruction. Water is one that's never mentioned. Because the perception is we've got a finite amount of water, there's a water cycle going on the planet, we're never going to use it up, but we'll come back to that to see why there's an environmental impact on water usage. And then another one that's often not mentioned because it's a more recent phenomenon is flooding and overheating. As we move towards the middle of the century, we're going to get a lot more of this. So we'll revisit this when we go down to the last section of this presentation, is how do we integrate all those aspects, all those features of sustainable building into our practice. The question now is, what is driving sustainable design? So I'm going to ask you again, what's driving you to build sustainably? Maybe you don't, maybe you can't, maybe you're not interested, maybe the client doesn't want you to, but is there anything that you might say, why would you want to build sustainably?
Preservation
Of
World.
Yes, okay. That's because you've got concern for the health of our home, which is kind of there. Thank you. Any other reasons why you might want to build sustainably or do?
It makes sense, financial sense as well, or economic sense for the client.
Okay, now that's really interesting. I can't say in my 30 years of doing this I've ever heard anybody say that. Most people say it's the opposite. I agree with you, by the way, but often cost is seen as an inhibitor. So that's very good to hear. Anything else?
Responsibility
To
yourself, your family, the human race.
yes, I'm loving this. I'm getting goose pimples. Sometimes it's because the client asks you to. If you're lucky, that's somebody will come to you and say, "I actually do want to make a difference with the building that I'm asking you to design." This does its own advancement. Or it might be because you have to, because there's some legislation. Now, there are many pieces of legislation. This one is possibly the most important one. So back in 2010, I think it was Gordon Brown, said that by 2050, I don't want to get the answer of this one, there we are. We are going to take a baseline, which is 1990 levels of CO2, and we're going to reduce it by a certain percentage below 1990 levels by mid-century. So, do you think it's 80 for... Yeah. No, you see that one. I'll do it with the computer. This is... Yeah, okay. So you've all seen that one, but you would have all got it right, wouldn't you?
I haven't seen it.
You haven't seen it? Okay. Anybody who didn't see that little red tick, anybody want to guess what it might be? So it's a percentage below 1990 levels of CO2 emissions.
Probably 40.
Probably 40. Yeah? Okay. Well, it is 80.
Oh, wow.
And that's a very robust target to meet. That's not just in the construction industry, it's everything that we do that creates carbon emissions. So industry, food, transport, everything. It's a very robust one. We're the only European country that has legally binding targets towards climate CO2 reduction. So some politicians might set a target that they don't really mind if they achieve it or not, because they'll either be dead or out of service by then. But rather than saying we're just going to get to 2049 and panic because we haven't got there, they've got 5 years stepped targets. So they have a carbon budget every 5 years that makes sure that we're getting towards that 2050 target, which is a practical way of doing things. We're not actually as far along as we had hoped. But it feeds back into what we then do for the next 5 years. We're going to come back to what else the government is or isn't doing. This was going to be an exercise where we got up and talked a little bit, but actually the room doesn't really lend itself to that. So I'm going to do it a slightly different way. Is who are the people who are driving sustainable design? I've got various choices for you here. So central government, local government, people who live and work in the buildings, NGOs like the Green Register and other organisations. NGO is a non-governmental organisation. The client might be driving it, we might be driving it, the developer might be driving it. I'm not going to say his name, but that person might be or the contractor, is that all of them? Or politicians. Okay, so what I had was sheets where you were going to go to 1 to 10 and write out what you thought. Because we can't do that here. What I'd like you to do is, the person or the organisation or the group of people is the most effective driver. So, let's see, how am I going to do this?
Who's currently the most effective driver?
Currently, yes, at the 2017. Okay, so I think the way I'm going to do this is put your hand up if you think, just trying to think of the best way of doing this. The government is the little group that's driving this most. Okay, 6 or 7 people. Okay, who thinks that we are driving it? Nobody. Yes, you should be. I think we are. How about the third one from the bottom? Anybody think that person is driving it?
Maybe by accident.
Yeah. Well, actually, it might be. It's unintentional that it might be.
Maybe we're driving in the right direction.
Yes. Well, he's trying to undo. I won't get into that. Okay, let's have a look at what the government's doing then, or what they're not doing, because quite a few of you, interestingly, put up your hands as the government being a driver. So you'll remember in 2010 that Cameron said that it's going to be the greenest government ever, which requires going to the North Pole and talking to huskies. However, 5 years later, we had what's called the bonfire of the red tape. So the government, in their wisdom, thought that in order to encourage development, we need to reduce all these standards and pieces of legislation and what were considered to be restrictions to development. We all know, as architects, that actually that isn't the reason why there wasn't more development. But a lot of things got cut. So we had the Home Information Pack, which was cut, the Code for Sustainable Homes. Whatever you think of it, it was one of the best methods of environmental assessment we have had. We had the Green Deal, which was the worst thing we could possibly have had. It was extremely badly managed. Subsidies for onshore wind farms cut. Both the zero carbon homes and the zero carbon hub were cut. However, we're going to come back to some of the legacy guides that they have produced. The renewable heat incentive subsidy for solar panels was brought forward, and feed-in tariffs. Now, feed-in tariff has got this double-edged sword there. So we've had a massive cull in all these drivers from the government, basically saying to people, don't worry, just do it business as usual. You don't have to build anything than above base level of building regs. So, what's left after the bonfire? What do we have in the embers? Well, we have something called MEES, which is the Minimum Energy Efficiency Standard. This is for rented property, and this is finally giving EPCs teeth. So if you've bought or sold a property in the last 10 years, you will probably have not thought very much of the EPC. It's really not worth the paper it's written on. However, it's about to get teeth in that by the middle of next year, landlords will no longer be legally allowed to rent properties that have an EPC of F and a G. So all of a sudden, those properties will become valueless because they will be unrentable in the legal market, which is fantastic. It means the worst performing buildings will have to be upgraded to at least an E. And then the next stage is they must not continue to let properties after 2023.
Can I ask a quick question about
Yes.
that? Have you any idea what proportion of rented properties fall into F&G at the moment?
No, that's a really good question though, actually. I don't.
Not that high. Unfortunately, it seems to be a way of getting around it by putting some LEDs in to replace the lights.
Right.
It actually takes you to an F or a G, takes you to an F standard by just replacing the light bulbs.
Right.
So the actual standard is set in 2018 is not very good.
My guess, I think that's right, it's not a very robust standard, but my guess is that what will happen is they'll ramp it up. So it'll start to be F and G is unlettable, and then they'll move into the G and into the E, so then it'll become a little bit more like you've actually got to put some measures in that work. The feed-in tariffs I've mentioned are a double-edged sword. So these are incentives for people to do microgeneration. Most people are using photovoltaics, PVs. And the idea is to encourage people to generate their own energy through renewable technologies. And back in 2010, the government was giving 45 pence per kilowatt hour of generated at home. We put our solar panels in at that point, our PVs. And it was index linked, so it's up to nearly 50p now. 2 years later, they reduced it to 16 pence a kilowatt hour. And the idea was as the more people put PVs in and the cost of PVs came down, the feed-in tariff would reduce correspondingly. And in December 2015, you'll remember that we and 774 other countries signed the Paris Accord. And in that same month, the government reduced the fix to basically 4 pence. And what had happened is industries had geared up to put lots of PV arrays in and other renewables, and the market collapsed because clients said, well, it's not worth me doing. 4p a kilowatt hour isn't worth it. Everybody knew it was the trajectory was towards reducing the tariff, but it was such a cliff edge drop that it closed a lot of companies, and it was a very poor method of doing that. However, the feed-in tariffs have reduced the cost of PVs by 70%. So we were early adopters. We paid £3,500 for a 1.2 kilowatt hour array, but actually that would have cost us £1,500 now. So it's done partly what it's meant to be. The EPCs, the previous speaker was talking about Brexit. The good news is that some of the law with this Energy Performance Buildings Directive is actually harmonised with our UK law. So whatever happens with Brexit, it's there till 2020 at least. It might even go into 2030. So we do have some areas where there's going to be environmental legislation. Having shut the Zero Carbon Hub and thrown out the Zero Carbon target, we now have nearly zero carbon buildings, or nearly zero energy buildings. And the timetable for that is that by the middle of the next year, 2018, all new public buildings will be near zero energy buildings, and by 2021, all new buildings will be near zero energy buildings. So we'll see how that pans out. This is the stages. You can download this document online, and firstly, what they're saying is zero energy is one that has so little energy that the energy that building needs is generated through renewables, either on site or somewhere close by. We've got all the assessment standards still, they're still in place, none of them are required any longer. So we've got BREEAM, you may have heard of LEED, it's an environmental standard which is making its way into the UK. I've mentioned this one already. Home Quality Mark is one that the BRE have introduced, and Passive House. So I wanted to talk very briefly to you about Passive House because Will and I are actually going to have a meeting about this afterwards. Anybody here a Passive House certifier? Passive House designer? No. Okay. You may or may not know that to become a designer, a certified designer, you have to go on a 2-week course. It's a lot of money, it's a lot of time out of the office. And we felt that the Passive House standard was important enough to try and create a bite-sized version of it. So we run them in London and Bristol. They're extremely well, they're very popular because they're run by the same trainers as the full courses, but it's just 4 half-day sessions. And we all kindly did some survey, sort of informal survey up here to see whether people up here would like 4 half-days in consecutive weeks or 2 full days, and I think that it was marginally more popular to have 2 full days. So I'm just going to pass this around. If you're interested in coming to the Passive House bite size, just put a tick next to your name as a yes or a no. I'm not going to hold you to this, but we need 12 people in order to run it. Sometime next year.
Can I just add?
Yes.
Just in terms of the reasons, probably one of the reasons why not many people put their hand up here and have looked into the practicalities of this is in order to do the training for the Passive House, and you're well aware of this, they're either Watford or the South East or Hereford, and there's nothing sort of north of Watford that does that training. For someone up here to go down there for 2 weeks and pay for their accommodation, miss work, it's just impractical, and
it's a lot of time.
But there are people up here who are qualified and they are trainers and I don't understand why that hasn't sort of manifested itself in a course up here.
Well, I think the idea, because we work with Warm, who are the people who do the full training, is that if we can get enough people to do the bite size, we'll be able to gauge whether it's worth doing the full 2 week course up here.
Yeah.
You know, the Green Regis are very keen to have a presence up in the northeast, and so we just want to see whether there's that initial interest. But thank you for that.
It's a nice one in London or something. One here, or is it going to be up here?
It would be here. So at the moment we're running one in London. We're going to have one in Bristol next year. But if we get enough interest, we would prefer to run it here. So let's also look at the architect. I don't know if you've ever Googled architect under images. This was 10 reasons why not to date an architect. I'd like to think the architect's the person on the left. But let's look at what we can do then. because that's the kind of meat of this. This is what the reason why Rory was to try and find out how we can influence change. And I'd like you just to tell me what you think a sustainable building looks like. I don't really mean aesthetically. I mean, what features would it have?
Well insulated, low,
Highly insulated. Yeah.
Good windows.
Okay, MVHR, good windows. So 2 lots of external envelope, 1 services.
Airtight.
Movable bits.
Airtight, movable bits. What kind of removable bits?
Movable.
Yes, movable. Like
Well,
partitions.
so it can respond, the building can change maintenance.
Yes. Okay.
More living walls.
Living
Living
walls.
walls.
Yes.
Lovely.
Yes, we like those. Yeah. Great. Using timber. Okay. Timber can be the best or the worst material from an environmental point of view. Daylight. Great. Grey water. Orientation. Great. All good aspects of a sustainable building. So we're going to actually go back to the list that we had looked at earlier and look at each of those separately. So I just want to make a point about energy, because when we talk about energy in buildings, we tend to talk about energy in use, which is right because half the national energy bill is used in servicing buildings. However, we're getting better energy efficient buildings in terms of the consumption of energy in the building. Therefore, the embodied energy, the energy that goes into making the components and the products, is proportionally getting bigger. It's about 8 to 10% at the moment. So the more we get good at doing energy efficiency in terms of energy in use, embodied energy becomes more important. And this is going to be even obvious to you, but when you use more energy, you're using fossil fuels predominantly, you're producing more CO2, which is producing climate change. So the better our buildings can be, the better the climate is going to be. Top 5 for energy efficiency, which is, as our colleague has said, to paraphrase Blair, insulation, insulation, insulation. So somebody mentioned refurbishment earlier. This is much more important in refurbishment, because if you build new buildings to current cartel, you're doing okay. It's not a bad standard to get to, although we will come back to whether we are actually building to cartel or not. But the point is that 40% of the buildings that we're going to be living and working in mid-century predate 1985, which if you're my age, you'll remember pre-1985 there was no concept of conservation of fuel and power. So we've got a lot of work to do with refurbishment. But there are some incredibly simple things to do with insulation. Very high carbon reduction, very low cost. Loft insulation. You can tell which one's got loft insulation here. Practically nothing in terms of cost, very high carbon saved. You then go on to things like wall insulation. This is my house. We put external wall insulation on a 9-inch wall with render. You can do internal insulation, which is possibly what people are considering with historic buildings or buildings where there's a nice exterior. Or you can do a hybrid, like we did, although don't do what we did, which is that. Yes. Okay. So this is the undeveloped house, but this is render, and this is a thermographic image of after the works were done. This has got 18mm polyisocyanurate on the outside. I wanted to keep this as a feature, so we internally insulated that with foam back plasterboard. What's that thermographic image showing? We didn't do. Yeah, why have we got cold bridge? There's no overlap. I know to do it now, but that there is where the internal insulation and external insulation don't overlap. So we have a very big cold bridge. However, I would really advise you to be very thoughtful when you do internal wall insulation for retrofit, well actually for both, but particularly for retrofit, because you're moving the dew point, you're possibly moving it within the fabric where it's going to cause destruction and deterioration of the fabric. This is a picture of some internal wall insulation which had to be ripped out because there was mould growing behind it. Historic Scotland was so concerned about this that they actually put moisture meters behind all the trial internal wall installations to see if the moisture went up as a result of the IWY. This is a report that you can get free online. It does actually conclude that there was no significant increase in moisture, but I would say that this was a very particular building, in a very particular climate, with a very particular set of internal wall insulation, so don't take that as read. It's a very serious issue. The next one for energy is passive solar. So would you like an energy source that's free? Yes? Okay. How about one that's free in carbon neutral? I think you know where I'm going with this. Virtually unlimited, no dodgy people turning the tap off because they get cross with us over borders. Well, you know what it is, it's the sun, and we don't use it because every hour the sun radiates more energy on the earth than the whole population uses in a year. We have so much potential in the sun that we don't use it. And I'm not necessarily talking about active systems, I'm talking about passive as well. I'm going to talk about the Zero Carbon Hub legacy of guides, and they've got one really good one called the Designer's Handbook. You're going to get all these slides so you'll be able to link to it. The Buildings Hub is the legacy organisation of the Zero Carbon Hub, so they both produce documents. But the Designer's Guide talks about passive design, particularly in context of passive house principles. And it talks about thermal mass, which is a very interesting concept to use passively rather than active systems. So do have a look at that. The benefits of thermal mass are twofold. They delay the inevitable peak in temperature by absorbing the heat, and they also flatten out the temperature. And when we did our external wall insulation, I decided that I wanted to monitor it for a year to see whether those principles of thermal mass came right in practice. So we had little thermal loggers in all parts of the house and one outside. The blue is the outside. So this was a week we went on to relatives at Christmas time. This is the temperature outside, hovering between about 5 and 10 degrees. Turned off the heating before we left. These are the 3 stories in the house, and temperature never went below 14 degrees because in the previous weeks we'd had the heating on, the 9-inch brick wall had absorbed the heat, there was a big tea cosy on the outside, and the heat had nowhere to go, and it retains the heat very well. This is a 24-hour period showing that actually the temperature is extremely even in a thermally massive building, particularly the tea cosy on the outside. So it was a week before, so it was a bit colder outside. At some point we had the heating on, but generally that's a very even temperature on in the house. So I was convinced that thermal mass was a good use of passive design. Okay, somebody mentioned airtightness earlier. It's drafts, basically. And the principle of airtightness is the same as if you're outside on a cold day with a woolly jumper and there's very still air, you'll be really warm. If you've got a breeze going through your woolly jumper, you'll feel cold. And so the idea is to wrap yourself in not necessarily a big thick jacket, but just something that's airtight and the wind can't go through it. It's exactly the same in buildings. Many people think that airtightness is not really significant. And this study that was done in Germany shows quite how shockingly significant small gaps are. So they designed a square metre of external wall, 140 mil of insulation, unbroken vapour check, and then they took Stanley knife and they cut a 1 millimetre gap across the 1 metre surface. The design U value was 0.3. What do you think doing that tiny little gap, which of course we never ever see on construction sites, did to the U value? What value do you think it resulted in? Take a guess.
Twice.
Twice. The other way around. What was the number? What was the figure?
It's 0.4.
1.6.
Who said 1.6? Anybody higher than 1.6? Okay. Factor of nearly 5.
Wow.
It acts like a prism. It's a very small gap to lose disproportionate amounts of air, and also moisture, by the way. So if you're doing timber frame, you've got gaps in the breather membrane, that moisture is going to get in and damage the timber. So actually air tightness is massively important, and we don't have robust enough regulations here at the moment. It's 10 air changes per hour, which is a hole the size of a 20p piece every square metre of the external envelope. It's not too difficult to achieve. The problem we've got as architects is we're often not on site to monitor it, so you have to identify a site champion that's going to look after the air tightness for you. The good news is that we are routinely getting better tightness values. This again is my house, so on the right is how not to do air tightness. This was just before we fell out with the first builder. On the left is my younger brother, who does do what he's told, and he was putting in a breather membrane in the ground floor. And what we were doing is the joists there were rotten because the flower beds had breached the DPC. So we took all the joists out, put a new one in. This is a section, opened up the air vents, and then I thought I was being really clever. I put a breathing membrane around the joists, stapled them to bottom so they're nice straight pockets, filled it with cellulose insulation, and then I put a plastic layer up and behind the skirting, and then fixed the skirting to the overlap, thinking that's where the problem is. That's where the leakage is going to be. But actually, in post-occupancy thermal imaging that I've done, there is a problem with that. And why would that be? What didn't we do? No, we did. We insulated the joists. But why would air be coming up where that arrow is?
Didn't seal it.
Didn't seal it. And what does plaster do below a skirting board? They don't bother plastering it in a nice fashion, they leave it out. So this good idea I had of the plastic going up and being held by the skirting, actually was being held against an irregular surface. So I should have taped the entire top of the plastic. I could not bring myself to ruin all the mitres of all the skirting around the ground floor, so I just put a whole load of silicone there for the time being, and I shall revisit it at some point. So this is what we as architects must do. You must communicate, particularly if it's design a building, you're going to have no site presence at all, is identify where your air tightness layer is. And whether you're using a mouse or a red pencil, if your pencil comes off the paper, that means you've got a gap. And remember what those gaps do to the air tightness. If your pencil jiggles a lot, it means it's a really difficult detail and you have to blow that up and show the contractor how to do it. But we must show the people on site where that air tightness layer is. Now, on to the performance gap. So, I'm going to show this in terms of energy use. This is using the READ plan of work. And I'm going to show you what happens. And the number of times I've shown this to people, most people say, yeah, that happens in our projects too. It isn't inevitable, but it is. So it's a slightly odd way of showing it. This is Part L compliance here. And above the line is better than Part L, no sorry, below the line is better than Part L, and above the line is non-compliance. So at the beginning, everybody's feeling very positive about the project. The client says, yes, we want to get a BREEAM standard, maybe we're going to get some funding for some renewables or something. The building modelling says actually we're going to be even better than that. And then by the time you've got a kind of design freeze, you've got a pretty good above compliance, better than compliance building. Then you start getting into technical design, things start to change, we start getting value engineering, loads started going up, they double the size of the computers in a school or something, and the air conditioning goes up, and that's where the design freeze is there. At that point, actually, you're just about to tip into non-compliance. Then you get the construction, and depending on what type of procurement it is, you start to get more value engineering, product substitution, change to specifications. There's a lot of pressure to get it finished, so people start speeding up, and quality is compromised. By the time you've handed it over and you're using the building, you've probably got a factor of 2 to 5 in what you have designed. And it is a non-compliant building, and there's no resources in building control to come back and look at that non-compliance. So your aspirations, your client's aspirations are very good, but actually by the time you've gone through that process, you've got a non-compliant building. So what we used to call post-occupancy monitoring, which is now called building performance evaluation, is incredibly important. So you can use things like the soft landings, which we'll come back to, which looks at the building over a number of years and feeds back the things that have possibly gone wrong, and crucially shares that information. You know, none of us will learn from our mistakes if we don't know what those mistakes are, and we're going to routinely build non-compliant buildings if we don't. The BP programme was an £8 million programme. I'm not going to spend long on this because it did highlight a lot of problems around the country in terms of build quality. There's a domestic programme and a non-domestic programme. They're all freely downloadable. The kind of things that they were using was thermography to show major gaps here. This is between the wallboard and the ceiling, where there's a huge thermal bridge across that junction. This was underfloor heating. The client couldn't understand why the underfloor heating wasn't keeping it warm. Brought in an electric fan heater to try and heat the building. And actually with thermographic imaging, you can see that only one panel of the underfloor heating is working. The rest isn't working. Although I just thought you could actually put your hand on the floor, couldn't you? Yes. This was another one where it was an unheated building. The thermostat was set at 12, but because it had been incorrectly wired, the boiler being told it needed to be heated up, and the actual air temperature was nearly 25 degrees. Post-occupancy monitoring showed that and was easily resolved, but otherwise you wouldn't know what was going on there. Ventilation is a whole other subject which we spent days talking at the Green Register about. There's a hideous amount of poor installations. Visria did a study of dwellings. 82% had ductwork incorrectly fitting, undersized fans, insufficient number of fans, even ducts filled with cavity wall insulation. So it's very important for us to try and share what goes wrong, even though it's hard for us to admit it. Soft landings is a Visria programme which goes for several years after the building's been built. The RIBA's got one in conjunction with SIPSI, so you can upload your information, share it and compare it with others. If you're unwilling to author it, that's fine, you can anonymise the data. But we need to share what's going wrong in order to make it right. Okay, renewable energy technologies. There's a difference between low carbon technologies and renewable energy technologies. Anybody care to just think what that might mean? They're not exactly the same.
People are putting log burners now, and it's a few boxes, isn't it?
It does, yep. So that might be what's considered a low carbon technology, but or maybe it's renewable. Depends where the wood's coming from. Not all technologies that save carbon are renewable. So our colleague was talking about LED lighting, fantastic. You know, quite a tiny tenth of the amount of energy that halogen lights produce, same light quality these days. So it saves a lot of carbon, but it's not renewable. Gas condensing boilers, they're not particularly sexy, but they are actually very efficient with the amount of gas that goes in. Up to 95% of the energy that goes in comes out as useful energy. Not all renewable technologies save carbon. Air source heat pumps is a very good example. It's just a fancy way of using electricity, and if you don't have a coefficient of performance of at least 3, you might as well be using gas. It's all relative though. All technologies have some kind of carbon emissions. Very simply put, those 3 are low carbon technologies but aren't renewables. So the time I've got left, this is going to be a bit whirlwind. The thing I want to point out is there's 2 types of solar thermal. If your client's interested in using the solar panels, there's 2 types of solar thermal. One is the flat plate on the top. Sorry, one is a flat plate on the bottom, and the one on the top is called evacuated tube. And the beauty of that is, particularly if you're retrofitting, what evacuated tubes have is a little fin inside with a pipe running through the middle, and you can tip the fin towards the sun. So if you haven't got an ideal south-facing roof, you can tip the roofs towards the sun. Another thing that was found out with the building performance evaluation was that in this particular case of evacuated tubes, they were in the wrong place, in the wrong orientation, and a third of the tubes were actually upside down. So, good to check. This is just a personal gripe. This was the last project that we did before I decided not to have clients anymore. And actually it wasn't the client's fault in this particular case, but it was a conservation area. This is a hotel. Our clients wanted to be the greenest hotel in the country, and we had a very small number of evacuated solar panels here, but the conservation officer didn't want that last set panel, which were there. We had to take them out because she said she could see them. And I absolutely promise you, you could only see these if you were up a tree. There is no way you could see that last panel, but we had to take it out. Photovoltaics, which is what most of the feed-in tariffs are using, it's such a good news story. So you can use it off-grid, integrated into glazing. That's the most common way of using it. Solar farms we've seen, even as cladding for buildings. Don't do that last one though. That's solar panels in the shade. I always put this one in because hydro is very important. It's unlike wind and solar. It's not dependent on the source. You know, as long as the stream is running, it's going. But most people don't have a river at the end of their site. I've mentioned wind farms. We've got more wind capacity than the whole of the rest of Europe because of our geographical position. But the government, in their wisdom, decided to remove the subsidy a year earlier than they did for onshore wind.
Don't like wind farms.
Pardon?
Don't like wind farms.
Don't like wind farms. It's a very emotive issue,
Yeah.
but I don't like nuclear power, and we have to have electricity somehow. Don't do this, which, pardon?
Other ways of doing it.
Energy efficiency is one of them.
Yes.
Don't do this, please. This is a building integrated wind turbine. Now, most wind turbines in urban areas don't generate sufficient. There's not sufficient wind because it's all cut up. I forget what it is. It might be 6 meters per second. So all this is doing is generating enough electricity, probably to light the sign that says we've got wind turbines on the roof. The reason why this is a good news story is that we're at a point where renewables are competitive to fossil fuels. So if you take nothing else away today, take one of these away, which is upstairs. It is in Bristol, I realise that. But just look at some of these figures. Portugal survived on nearly 5 days last May with nothing but renewable energy. Even here, you know, I'm fairly long in the tooth. It's always been in single figures, the percentage of energy that's generated through renewables. It's 25% last year in the UK. I mentioned about the cost of PV panels. Have a look at this documentary. You will never think again about fossil fuels in the same way. It is 45 minutes long. It's not made by aging hippies like me. It's made by hard-nosed investors who are saying renewable energy is here. It is now competitive. Solar panels are being made by the gazillion hectares in China, and we're really about to reach a tipping point. And it's very interesting that we are here in the Mining Institute because back in April was the first day since the Industrial Revolution that we used energy without any coal. I'm not going to have time to do any of these other ones unless I am allowed to speak at all. Yeah. It's now my time's up.
We've got a couple of minutes.
I know. Well, tell me to stop. I mean now?
2 more minutes.
2 minutes, okay. So, I'm going to go straight to that one, which is, I really like it because it just sums up what we do with stuff. We take stuff out of the ground, we make it into something, we use it for a bit, and then we throw it away. And that's what we do with building materials too. And there's lots of links on the slides, but lots of really good organisations that are doing things about reducing waste, using materials with recycled content, and that sort of thing. So do take a look at the references that I put on there. What we do with 13 million tonnes is it goes straight from the back of, instead of cradle to grave, it's cradle to skip. This is what we do. We put most of the stuff in a big hole and ask our children to deal with it. We do very little of this at the top. And if you reverse it, you do very little landfill and mostly prevention in the first place. So this is the other one I wanted to mention because nobody ever mentions water. So what we have is in the UK, lots of water here, lots of people here. And because we can't have a water grid like we have an electricity grid, we have to provide local solutions. So here's some suggestions that you probably are doing already, to be honest. So it's not so much about doing something with the water once it's been used, it's about reducing water in the first place, the point of use. So low flush toilets, dual flush toilets, you know, again, that's much more routine these days. Aerators to make the water mix with air. Low flow shower heads, don't use power showers, they in 5 minutes use more than a bath. Rainwater, that's an independent organisation for rainwater harvesting. Washing machines love rainwater, obviously plants love it. You can use it to flush toilets, you know, you don't need potable water to flush the toilet. Rainwater is debatable because you have to treat it, so avoid that. But it also requires behavioural change. You know, things like if it's yellow, let it mellow, if it's brown, flush it down. And then I think I'm going to, this is just the one other one, which is about sea level rises. So, you know, you see pictures of polar bears and ice caps and all the rest of it, but actually that is what's happening is the climate is warming, and buildings have a big influence on that because we use fossil fuels and that increases the global warming. So we can affect this, but we are on an island which is surrounded by water, and this is sea level rises since 1850. There we are, practically where that circle is, and you can see in all cases sea level rises are going up. Yeah, I'm sorry, I don't have time to go through all this. Well, do have a look at this though. This is the Zero Carbon Hub Services Guide. It's got a lot of overheating, lots on overheating. Really good section on ventilation too. So I was mentioning how poor installations are. You know, these are the kinds of things not to do. No more than 300 mil of flexi duct. It's got to be rigid because it just, you know, increases the resistance of the air and so on. Lots of really good practical solutions you can find, all free to download. I very much encourage you to take a look at all those guides. And so to finish, the future isn't dark, it's not full of coal, it's full of the sun. Thank you.